Hey everyone, welcome to another video. Before we get started, if you could please like and subscribe, that would help us out a lot. And if you're curious in doing a mock interview with us or checking out any of our other services, then definitely check out the links in the description to our website or the form you can fill out. So today we have an easy LeetCode question called search insert position. So the general idea with this one is that you have an array that's sorted and a target value, and your goal is to return the index of that target if it's found in the list. Otherwise, you want to return the index where it would be if it were inserted in order. So basically we want to maintain the sorted nature of our list, and if the number is not found, we want to insert it at that position, and the only thing we have to return is the index where we would do that insertion. So off the bat, a really easy solution for this one would just be a linear scan and basically compare our target value with each number for every iteration through our list. If at any point our target is less than the number, then we know that we just want to return that index because it's zero index, so we're just going to scan our way through. So basically, a nice way to do this is use the enumerate keywords. That way we can have our index and number by name throughout our loop. It'll make things a little bit more readable. So for that, we can just say for index and num in enumerate nums. So here we are keeping track of our index and our number at every iteration by the name of index and num. So the first case would be if the number equals our target. So basically, if our target is found at any iteration, then we just want to return that index because we know exactly where it is. So for that, we can just say if our num equals our target, then we know we just want to return the index that we're currently sitting at within this iteration. So then the next case would be if it's not found, and for that one we can just say that if our number is greater than our target, then we just want to return the index we're at. So basically, if you look at this example here, we have the number 2, and it needs to go at index 1 here. So we see that num, which is 3, in this second iteration here, this will return true here, and then we'll just return an index of 1. So now it might not be apparent right away, but you'll notice that we have to basically catch the case where the index that the element has to go into is at the very end. So for that, if both of these conditions fail throughout our loop, then all we have to do is just return the length of our nums, basically the input list, because we know it's going to go at the end. So this is an O of N solution. It doesn't use any extra space, which is good. But one of the keywords in this question is that it is a sorted array. So anytime you see sorted, I mentioned this in a previous video, but the first thing, if you have a sorted list of numbers, is you should start thinking about binary search. So this one is going to use binary search similar to another video we did, and it's a very slight modification, if you could even call it that. So as I mentioned, this here O of N solution, it's pretty good, definitely the sort of naive brute force solution. So as I mentioned, we're going to start looking into the binary search solution. So we know that basically we have a sorted list and a target, and if we just think about what binary search does, we're going to get log of n runtime, and we can find that index with the same conditions we had, where we're just basically looking for where our target is less than or greater than basically than the target. Then we can just do pretty much a slightly modified binary search that really doesn't check for when they're equal here. So let's start coding that one up, and we can explain it as we go. So just like in every binary search, we need to have our low, which is going to be 0, and our high index, which is going to be the length of our nums. So then after this, we can just start setting up our condition, our while loop condition, which is just while low is less than high, to make sure that when our 2 pointers kind of crawl into each other, we don't go on forever, and we stop when they cross. So now what we'll do is we set our midpoint, similar to how you would in any other binary search. So we can just say our midpoint is equal to our low plus our high, and we can just make sure we get the floor, so we don't get a float with Python 3 here, and we now set our midpoint. So now we can start working through at every iteration of this binary search what we want to do. So if our target, which again is what we're looking for, is greater than what we have at our midpoint, then what we want to do is reassign our low pointer to our midpoint plus 1, because we know that it's not going to be on the left side. Our target is greater than where we currently sit. So in this case here, the first iteration will say that it goes to 5 here. We see that 7 is greater, so we know that we just want to start moving to the right side of the array. Larger input would make it a little bit more clear, but I hope that this still makes some sense. So as I mentioned, we'll reassign our low to mid plus 1. And then otherwise, we can just reassign our high pointer equal to our midpoint. So now, in binary search, a lot of times you're searching for a target, and a lot of times the first condition you have is that if basically if your target at that point is equal to, the target at the midpoint is what you're looking for, then you're good to go, and you can return the index if you want, or whatever it is. But with this one, we're basically using our low pointer as assigning where the index we want to return is. So all we have to do is that once this condition, this while loop condition here, is done, we can just return whatever low ends up being. So it might not be immediately apparent what's happening, but low is basically going to be equal to our high point plus 1. So as we kind of crawl through this, we want the index at that point, and our low is going to keep track of where that trailing index and what we want to return is. So why don't we go ahead and run this, make sure we didn't rate any bugs. And we'll see we have 2140. So we get what we expect, and basically what we just did is we took our sort of naive linear approach, which was just looping through one time. We recognized that it was sorted, which means we can most likely use binary search, and then we decided that to use that binary search to get us down to O of log n runtime. So thank you very much for this one. It was an easy LeetCode, definitely. We're going to start getting a little bit more difficult, but we wanted to kind of start off with some of the more simple ones, stuff you'll see in code screens if you're looking for internships or co-ops or even entry-level jobs. These sort of easy show-me-you-can-code questions will definitely come up. So thank you very much. And again, be sure to check out our mock interviews and resume reviews and things like that with the links in the description.